Bismillahirrahmanirrahim. Okay, in the previous video we talked about the decision tree, and we said that decision tree is a very important classifier that we could use for classifying nominal data. Okay, we said that in the decision tree the learning model is a tree. Okay, the learning model is a tree. The learning model, as we said before, is the format of the relation between the inputs and output. So here we have a tree that wants to represent the relation between the inputs and output. Okay, the most important thing about the decision tree is the building of the tree. Okay, building the tree is the most important thing that we are doing for the decision tree. Okay, when we want to build the tree, the most important thing is selecting the best features to put into the tree. Okay, so when we want to build the tree, the most important thing is selecting the best features in the tree. Okay, how do we do this? How do we do this? How do we select the best features in the tree? Okay, as you saw in the previous slides, in this tree, okay, here we have some features. Okay, okay, now how do we select the best trees? How do we select the best features to put in the tree? Okay, in the ID3 decision tree, okay, we are talking about the ID3. ID3 uh, is one of the decision trees that we have. In ID3, the best features are selected using a metric called information gain. Okay, so information gain is the metric used for selecting the best features. Okay, now we want to know what is the information gain. What does information gain mean? Information gain is a metric which is based on another concept named entropy. Okay, now what is entropy? If we have a data S, S is our data. The entropy of this data could be calculated using this formula. Okay, in this formula we are doing a summation. I is equal 1 to C. What is C? C is the number of classes. For example, if we are working for fruit classification and we have 5 fruits, then C is equal to 5. So for each class we are computing this. Okay, we are calculating this term. Okay, what is PI? PI means the probability of data being in that class. I is the index of the class. Logarithm pi. Again, negative pi multiplied by logarithm in the base 2 of pi. For example, if our data has two classes, the entropy of S is equal to this, and the two classes are positive and negative. Okay, minus the probability of positive data, okay, logarithm of this, and probability of negative data, logarithm. Okay, this is entropy. So if we have a data that this data it has multiple classes, we could calculate the entropy using this formula. Example, if we have this data, okay, this data, here you see that this data has 8 rows, 1, 2 to 8 rows, and in this data it's about tennis, the sport tennis, and this column, it is the class, it is the output or the class. Okay, so in this data we have two classes, no and yes. Okay, we have two classes, no, yes. And so now we want to calculate entropy. Entropy D1 to D8. D1 to D8. Okay, we want to calculate the entropy. We say that, okay, positive it means yes. Positive is yes, and negative is no. Okay, this negative is no and positive is yes. Minus the probability of positive. Okay, positive. Here, the probability is the number of positive to the whole. Okay, we have 6 positives and the whole of them 8. So it's 6 divided by 8. This is the probability of positive. And then logarithm this probability. And then minus the probability of negative, logarithm the probability of negative. Okay, and this will come to this value, 0.24. This is the entropy of this data, 0.24. Okay, the best value for entropy is 0. If the entropy is 0, it means that all of the data have the same class. Okay, if all of the data, for example, are yes, the output of all of the data is yes, what happens? Here you see that this would be minus 8 divided by 8. Okay, logarithm 8 divided by 8. Okay, logarithm 8 divided by 8, it means logarithm 1, and logarithm 1 is equal to 0. And here the probability of the negative class, it is 0. So the entropy would be 0. Okay, this is the best situation of entropy, when it is 0. And the worst situation of entropy is 1. So entropy is a value between 0 and 1. The worst value is 1. When does this occur? It occurs when we have the same number of data in different classes. For example, here we have 8 data. 4 of them is no and 4 of them is yes. If you calculate this, you will see that the entropy would be 1. Okay? Okay. So this is entropy. This is entropy, a value that we have here. Now, we said that in ID3, information gain is used to select the best features. Okay? Now, what is information gain? This is the formula of information gain. Sorry. This is the formula of information gain. If we have a data S and we have an attribute A, the information gain of attribute A in data S is equal to entropy S minus this value. Okay. So the information gain of an attribute could be calculated using this term. Okay, first we have to calculate the entropy, and then we should calculate the entropy for the attribute. Okay, let's look at an example of this. How could we calculate the information gain for a feature? Okay, again, assume we have this data. Okay, we have this data, and in this data, what do we want to do? We want to calculate the gain of the feature wind. Okay, this feature. We want to calculate the gain, the information gain of the feature wind in this data. S is this data that we have here. Okay, S is this data. Okay, so we want to calculate the information gain of the feature wind. Okay. In this slide, you can see that we are calculating the information gain. Okay. You see that for this feature, the feature wind, we have these values. This is the values of feature wind. The feature wind, the values are weak or strong. As you see, this feature is a nominal feature. The values are string values, and the number of values is limited, only 2 values. Okay, now in S this is the data. In the previous slide, you see that this here we have 14 data, D1, D14, 14 data. Okay, now in this 14 data, 9 of them is positive and 5 is negative. If you look, and yes means positive and no means negative, and 9 is positive and 5 is negative. Okay, then if we look in the data which the wind feature has the value weak, in this data we have 6 positive and 2 negative, and in the data which the wind feature has the value strong, we have 3 positive, 3 negative. Okay, and this is the gain of the feature wind in the data S. equal to entropy S. Entropy S, it could be calculated using this data, okay, and the formula that we have in the previous slides. And then this term, okay, entropy S, the value of entropy S is 0.94, and this one S weak. S weak means the data which the wind feature is weak. We said 6 positive and 2 negative. Okay, so this is the entropy. We put it here, and the value of the entropy is 0.8. And for S is strong, it means the data that the wind feature, it has the value is strong. The entropy is 1. Okay. Okay. Now, what is this 8 divided by 14? It means that it means that from the all of the data that we have 14 data. From these 14 data, 8 of them have the wind value, the wind feature has the value weak, and 6 of them the wind feature has the value strong. So we have written this 8 divided by 14, it is this term in the formula. Okay, so the gain of the feature wind finally is this 0.04. Okay, this is the gain for the feature wind in the data. So we could calculate the gain for different features, and then we could select the best feature. The best feature is the feature which has the highest gain. Okay, the best feature is the feature which has the highest gain. Okay, so that's enough for now. And I said that the decision tree is a classifier which could be used for classifying nominal data. And we talked about, and we said that in this classifier the learning model is a tree, and we want to build a tree. And in this tree, the most important thing for building a tree is how to select the features, because in the decision tree, in the nodes of the decision tree, we have some features, so we have to select the best features. Okay, in the ID tree, decision tree, for selecting the best feature, there is a metric named information gain that I talked about it, and we see that how could we calculate the information gain. Okay, thank you. We will talk about this subject in the next sessions. Thank you very much.